Deep images are images that can contain any number of depth layers stored per pixel in the image. This is more advanced than having an image and a separate depth map or a Z-channel. It is also more advanced than having just layers of an image. So starting with DaVinci Resolve 20 or Fusion Studio version 20, we got the deep image compositing tools in Fusion. I will show you how they work. I will show you how you can work with deep image EXR files, show you how you can create deep image files directly in Fusion if you have the depth information available, and we'll show you how you can create deep images from the Fusion classical render node. All of this is intended as an introductory tutorial into that topic. It is most relevant for CG artists, but perhaps it's also interesting for anybody interested in the technology. I am doing today's tutorial in Fusion Studio and not in DaVinci Resolve. The reason is I'm on the very first beta release while recording this, and in my DaVinci Resolve version, when I work with deep image tools, I'm currently experiencing some GPU issue. I hope that's an early beta problem which will hopefully get fixed very soon. The tools are the same, so if you work in DaVinci Resolve anytime later when you watch this tutorial, that should work just the same as what I'm showing you here in Fusion Studio. I have in front of me a Fusion loader node. It could be a media in node in DaVinci Resolve with an EXR file sequence, which I rendered from Blender from this simple test scene. And I used the Octane Blender edition, which has the Octane render node in there. The reason is that Otoy's Octane renderer supports deep image EXR output. You cannot get directly deep image EXR files from like Cycles or Eevee. The ones that supported are Octane, and RenderMan should also be able to do it. However, I failed to get the files out. That's probably my mistake and not the mistake from RenderMan, but I couldn't figure it out. So I used this one for this demonstration and test. So in Fusion, I'm getting a regular EXR file sequence. Again, it can come from the media pool in DaVinci Resolve or via a Fusion loader node. Both is fine, whichever you prefer. You can see that this is a deep EXR once you go to the format section. And here you can choose, as long as nothing is connected, how you want to use this. Because if you set this to flat image, then it's just a regular, in this case, 32-bit float HD image. It has automatically a Z channel, but otherwise it's just any other EXR render sequence, and you can keep working on it with your 2D tools. As soon as I disconnect it, it will by default switch again to deep image, and a deep image cannot be connected to 2D tools because it is something different, even though the viewer can show it, but you also see in the viewer it says deep 32, so this is something different. This will not go to your media out or directly into your render. It will not be processable with 2D image tools. Instead, you need to use your deep image tools, and then at the very end you have deep to image, which is the final tool, like a render tool. This one can be connected to your 2D chain and go to your media out or saver nodes. And before that, you have your deep tool chain where you can use all those deep image tools. Speaking about the naming convention, we see deep image and deep pixel. Deep pixel is, this is like the traditional thing that has been there before deep images were even invented. So deep pixel just means image with Z channel or with any form of depth information. You might have positional information. In addition, you can have normal vectors and so on, which you just get as additional image passes, right? So we've had this for a long time. This has some disadvantages compared to the deep image, which actually have pixel values stored on multiple depth levels. So we'll come to the difference in a second. First of all, so this will be your general setup, and then you can continue. I'll delete this, but you can continue in 2D however you want. Let me first show you the depth information by using deep to points. And I'll just bring this out because this will not go directly to an image, but this goes into a 3D output and shows you the points that are in the image in 3D space. So let's bring this into the viewer, and here it is. It looks pretty flat, but this is because of the scale. So the image has the depth layers, but without reference to a camera, you don't really know how far away, like how stretched out it should be in the depth direction. That's why you can adjust that here, and you can use that to get a first idea of the image. However, without having the camera, you really don't know precisely what happened. So here, for example, we see the pixels moving around. In reality, probably the image was still and the camera was moving, right? But just from the pixels, it's impossible to know the difference. That's why instead of setting this, it's better to attach a camera. And if you can export your camera, I did that already, and I did a simple FBX export from Blender, where I got my camera from an FBX export, and then I can attach this and things reset and realign to however the camera was set up and how the scene was set up. And now this looks much better, right? So the pixels stay in place and the camera moves instead. You see pixels popping up on the side because, of course, we are only capturing the pixels that the camera actually captured during render time. That also means that there are not complete layers. For example, this background here, of course, didn't have a hole when I modeled it. However, it has a hole here because this sphere here is solid by design. So everything that's behind this sphere will not be ever seen by the camera, and therefore those pixels aren't visible. Let me do one tweak here and bring the density up. So density 0.1 is good for performance, but now for demonstration we can see a bit clearer if I actually show every single pixel in 3D with an HD image. That should be totally fine. So we see a bit better what's going on here. So this sphere here was completely solid. That's why we never see the back of the sphere. The camera, those pixels are irrelevant for the render. However, the spheres here in the front, they look a bit funny. They are semi-transparent and you can see through. You probably have like some shiny edges and so on where you don't see like every like why this is not full, right? Because once I go into camera position, this kind of fits together and yeah, comes closer so that we don't see these gaps anymore, and it is starting to look more like a semi-transparent sphere, what it is. And this sphere does have a back side of the sphere, which does contribute to the image, and which you see here. Same for the red sphere, so you see some parts from the back. And then we can also see the text that is behind the sphere, and we can see through the sphere, except for some areas where perhaps due to lighting effects or so, something is completely blocked, but otherwise we see the pixels through. What can we do with this? Well, we can start to use this for compositing, for example. Let's do a quick test and let's just add another text in here. And let me write deep image compositing, and I bring this in with a merge 3D because we are in a 3D system now. And let's probably I need to scale things up because from Blender usually if you don't change the scaling things tend to be larger, I think. And where is the text? It's here. I'll just bring it like in the middle of that green sphere and make it a bit lower. Let's see, from direction of the camera, more or less. Yeah, I think that's enough to get the idea. Now let's render this. And you will see if I go into the render node that I'm only seeing the compositing, the text, and not my points, because by default they're not renderable, which is good because you don't want to set lots of points into 3D and then just render them back. Instead, what we can do now is we can set the output of our render engine to deep image. And when we do this, we can combine this with the existing deep image. So let me take the output over output, which usually gives a merge. And in this case, it gives me a demerge which is a depth merge. It's similar to a 3D merge or a multi-merge, so you can merge as many elements as you want, and they are aligned by depth. And you can see now in the output, in the deep image, and then finally in the 2D image, that we have this all together. And here's something is cut off. Let me check my camera, because sometimes I know when I import cameras from Blender, sometimes the near slider isn't close enough. Right, so this is sometimes not imported correctly. I know that, that's why I'm changing that. So now the camera is capturing the entire word, and I see that I didn't position it so that we have transparency. So let's fix that and go back into 3D space here. And I thought I had, well, there should be a little bit, but let's position this again. I will just bring it further. Let's just make it super obvious. Let's even bring it behind the word image here. Let's see how it looks now. Yeah, so now we have it behind. We definitely have semi-transparency going on, right? This is solid, so this is covering it up, but the spheres are semi-transparent. And this is working perfectly fine. Just in case it's not clear, let's demonstrate the difference between this deep image merge and a simple merge based on depth channel. I think to most of you this might be clear already, especially if you have some experience with CG and with working with depth channels. But the main problem is a depth channel, as it comes out at the end, just has depth information per pixel, but each pixel can only have one depth. So here we have multiple levels, right? We have like a foreground of the sphere, background of the sphere, something that is now going into the middle, and one depth channel can simply not represent this correctly. Nonetheless, just to make it super clear, let me demonstrate. I will render this same text out as a regular image. Here we have an image and it does contain a depth channel. This one here also contains a depth channel because that's how I rendered it. And now if I just merge the two together, and in the channels I can enable depth merge, then the depth information is being used. That works more or less fine for the word deep image here, but it does not work for the semi-transparent areas at all, because the depth channel will say that this is all in the front, even though it should be in the front and in the back it should be semi-transparent. There is another difference, and that is that the depth channel is very often creating really bad edges. And the reason is that we have semi-transparency at edges because of anti-aliasing, where edges don't perfectly match the pixel grid. We get like softness from the interpolation. It could also be motion blur. It can be depth of field effects. So we usually have a lot of softness in any image. And if you zoom in on the edges, you usually see it. And that's where working with a simple depth channel fails. This is an extreme example if you're compositing a new element. If you do some slight color corrections, sometimes you can get away with it. But look at the edges, because very often, even blur effects and color correction effects and so on, very often you start to see problems at your edges. And back to the version from the deep compositing, here you see we maintain the softness of the edge. Now the semi-transparent spheres just show us an exaggerated version of the same problem. Let me remove the additional testing here and point out something else. Unfortunately, the render engine here does have some limits in the quality of the deep image that is being generated. You might even see it here if you switch between software and hardware renderer. Sometimes the output does not look the same, whether you output a deep image or regular one. Let me disconnect for a second. So this is the regular image output, this is the deep image output, and you see that even here we have from our render engine some problems. I hope that this gets improved at some point. At the moment I would probably go for the software render, which seems to be a bit better, but even this one will not work for more advanced volumetric stuff, like if you do particle stuff, for example. I have tried that beforehand and set up a smokestack, or this is the one you find in the templates. If I bring this into the scene here, let's see where it is. Oops. There's the smoke. So far so good, but when I do that as a deep image and start to merge it again, you see there's some transparency problems creeping in that really shouldn't be there. Yeah, so there are some issues with transparency and some issues with anti-aliasing of that render engine here. So I think this will work for like some simple text if you use the software renderer. It will also work if you like position image planes. If you have other like 2D elements and you use 3D to position them in space for pre-rendered elements, etc., that should work. If you think of more sophisticated particle animations, particularly, I think at the moment the quality of the output from that deep image is having some issues here. So I'll disconnect my smokestack again. Now, what else can we do here? You have some options to crop and hold out, resize. Some of this is pretty simple. It does what it says. So resize just changes the image dimensions. Transform will just move things in depth. So you can scale and transform in depth. So that's pretty much what you might think it would be. There is a holdout and a crop, and of course the image to deep. So image to deep will allow you to take an image. Here I have one. And bring that image into a deep image format at a specific depth, or if that image has a depth channel, this one does not, but I'll show you another example later, then you can directly position this and then use the depth offset or scale to bring it in the right place. You can move it like left and right, up, down here, or you could also in 2D, of course, add a transform and use that to position, or if you want it smaller, you can use that to position elements at a fixed depth or variable depth if the image already includes a depth channel. Before I go to this, a few more other small and interesting parts. Let's disconnect this again for a second. So the crop can be useful if you want to take away certain layers of the image. So let's say you want to remove parts of the background. You can sample here in the front. Let's bring this all the way to the front and then sample wherever you want to crop. So you have the option to take something away in the crop, and you could turn it around to get it behind. A holdout is somewhat similar, just that you have an image input to decide on the holdout. Let's remove the crop and show you the holdout very quickly. So here you can just use a background image. It has to be an RGB image. I'm not sure why you can't directly attach a mask. Now this background is completely blocking everything. Let's attach a mask to the background. Perhaps that could be a use case. And then we can choose again the depth level where this holdout should apply, and we could use this potentially to eliminate certain areas of an image, or take certain images out, to eliminate or extract certain areas, and then perhaps use them as masks for other operations, or do image processing on this and then combine it again. This is also an idea if you want to have depth effects and actually use the deep image feature. Again, you have seen the problems that you have when you use a depth map. So you have these deep pixel tools where you can, for example, create fog, or you can do a depth blur. But this is all based on the Z channel, which we have seen can cause problems. Now, if you wanted to, you could dissect this image into multiple layers of depth, process them individually, and then combine them again together. Let me show you this in a slightly advanced version for those of you who are interested in seeing some advanced trickery. Let me set this up, and this will take a few minutes, and if it's too advanced for you, feel free to step over it. But what I will do is I will use the crop node, and I will quickly add myself a few additional controls so that I have this crop in the most flexible way I can think of. Let me show you. I go to Edit Controls, and I create some additional sliders as slider controls, and I put them under controls. And let me do this in accelerated speed. Okay, I have a depth minimum and maximum slider, some divisions, an increment, and a current slice number that I want to set. I have added these. They don't do anything right now, but the way I want to use this is I want to first determine here the minimum and the maximum in terms of my Z channel. Let's have a look at that crop and make sure that we are not cropping anything and really have everything. All right, so I will now copy this into minimum and maximum. And then I have set a certain number of divisions here. I put the default to 5 for now for this example. And here I'll add an expression where I calculate how this divided by 5. So I take the maximum minus the minimum to calculate a step width kind of, or like a width of the slices that I want to generate, and divide this by the number of divisions. So if I want, I can change it to 10 later if I need more. And I am now using this to calculate the current slice, and this will work as follows with another expression where I use here the minimum plus, and then we take the current slice number minus 1 for the beginning. So if we are on slice number 1, we just use the minimum because this will evaluate to 0. And if we are on any further slice, we use the increment to decide how far away we are from the minimum. And the very same goes for the maximum, just without the minus 1. So here we use the full slice number, so we always go from the last slice, from the end of the last slice to the current slice. And with this slice number, I should be able to slice through all the way to the end from 1 to 5, because I used 5 divisions here. So with this setup, I'll use slice number 5 first, and then I use the deep to image the way it's here. So here I have my background slice, and my goal is to merge all the slices in 2D, so I can do 2D processing based on the slices I'm getting from my deep image. So here I'm copying this. Let me copy this 1, 2, 3, 4 times for 5 slices, hook it all up, set the slice number 5, 4, 3, 2, 1, and then from the back just merge it together. So this way I have reconstructed my image based on 5 slices, and now if I have operations that go through the depth, I could put them in the middle here. So let's say I want to do a depth blur. A depth blur should blur a lot at the very end and very little at the front. So what we can do is we can add a blur node here and then let this blur just a little bit, but then add another blur that blurs over it and again over it and again over it. And the way how that works then in practice is that from the back to the front we have like incremental steps where we are again taking the previous image and blurring again, and blurring multiple times is the same as blurring with a larger radius. I've tested that, and you can mathematically verify that, but that's not the point here. So this is kind of how you could build up a blur, and the reason why I'm building it up is because this image can contain pixels that are then partially occluded in the next level or the next level and so on. And by building this up incrementally, we have a chance of a better quality across the image, and we have a chance to blur like behind the semi-transparent areas, right? So that's the idea. To set this up equally, now I will take the blur and then Control-C to copy and Control-Shift-V to make an instance copy. Control-Shift-V, or right-click and find it in the menu, but that's simple enough. So I have added this here. Now all of these blurs have now the same radius, and we can go to 0 to a lot. And the only problem we see here is that there is some transparency creeping in. We can turn it off, but then there is darkness creeping in. So there is still a problem here because we have like some pixels that go beyond. This is a bit tough to fix in this particular example. We could potentially set up our slices a bit better, or we could try to fill this. One way to fill it is to, if we ignore the transparency on the edge for now, we could just expand this. One way I like to do this is with a tool that is designed for keying, with a clean plate tool. If you take a clean plate and sample some pixel, you can grow edges. And if you grow the edges here, that means that in the next step, you are kind of removing the transparency problem, because you're ensuring that the pixel values are propagated into the transparent areas, and you're not getting dark pixels by blurring from the transparency back into it. In this case, let me just click fill and ignore the problem on the side. It's not perfect here. We would have to do this multiple times. There are some issues here with the transparency in this case. If you have less transparency, or depending on your setup, how your layers are, it is less of a problem. If you want to fix this perfectly, it really takes some investment, or you might have to think about a better solution to fix this. The best solution would obviously, if Blackmagic Design created, for example, a deep image blur tool for us. Let's see, I don't know if they go in this direction. I think the tools we see here at the moment are basically the same that are in Nuke, so I think that's what they emulated. But we'll see if we get more deep tools like the deep pixel tools here, like a fork tool, perhaps some shader for relighting, stuff like that would be interesting for deep images as well. But I think this is enough to illustrate the idea. So here I'm really blurring more behind the transparency than I'm blurring this sphere here in the front, and that's what I kind of wanted to demonstrate with this idea, even though it's getting a little bit tricky to do it really well. Finally, I want to show you how you can create your own deep images if you cannot render them. If you are using a different render engine which does not support deep images, like any game engine, they won't support deep images as far as I'm aware. The default Eevee and Cycles engines from Blender don't support deep images. Nevertheless, you can create deep images in Fusion. You can even save them to disk as OpenEXR, deep OpenEXR 2.0. So you can do that. So here I have two render layers from the same CG render. It was rendered together. The lighting is for the entire scene, but then the render engine separated it out for me into two layers, a foreground and a background. In this case, the background is solid. So for example, my depth blur trick would work much better here than on the deep images actually. The background includes the shadows from the foreground, right? And the foreground includes like the indirect lighting and reflections from the background. You can do that via layered rendering, or creating render layers in your rendering software, and then using the indirect lighting, turning it on. This is sometimes a little bit tricky to set up depending on your render engine, but most systems can do that. And now we could, of course, in 2D merge this together and we have our final scene, very simple. Or we could first go into the deep image toolchain by using image to deep. And because both of them have a Z channel, we directly get a deep image that we can merge together. You see that foreground and background are not directly working. The background is blocking everything. One thing to pay attention is the scale of the Z channel, depending on how you render that. So you see that the image to deep by default changes the Z scale with a factor of -1. The reason is that in Fusion by default, if you go from the Fusion render engine, by default the Z depth goes into negative Z direction. It's just the orientation of the 3D system in Fusion, and everything is kind of aligned to that. So that's how typically Fusion used depth channels going into negative Z. However, OpenEXR 2.0, I think the standard is to go into positive Z. Doesn't really matter. You just have to be aware if you render from one system and it gives you positive Z like Blender does, and you go into another system and it has negative Z, you have to make sure if this conversion is warranted or not. In this case, if you look at the Z channel at the bottom here, you see that Blender is giving me a positive Z channel already. So this conversion is simply not correct for my Blender export, the way I exported it. So I don't need this, and now this is correct. And now we can, in this case, let me just simply use a text element and bring this one also into the same system here, and we can now position this in depth or sample. Let's start by bringing it somewhere here. And here you see, if I zoom in, you see terrible edges. Why is that? Because, well, we do have the Z depth from this coffee maker, and there are different levels of Z here. However, this is just one layer, right? It's the same as simply working with a normal image and a depth layer. If we are in this layer, then we will not get any great results as we are cutting through here. However, if I go behind it, let's sample behind, then you will see now we are between the layers that we put into our deep image, and here our deep compositing is working perfectly and we get smooth edges. Let's just quickly illustrate it one more time with the deep to points to see how this looks like. And this time I didn't bother about the camera, but it will be enough to simply set this probably to 1 or so. And you see how things are set up. Let's bring the density to 1 as well. So in this case, we see the coffee maker from the front and as per the Z values of the coffee maker, and the background layer, no holes this time because we have a complete layer with the according Z levels and then the text that we manually positioned. So this can be useful if you are working with multiple render layers. The question is, do you set it up or do you work in 2D? Because of course we could also in 2D set up a merge where this layer is in front of this layer and this one is in between. We can arrange that in 2D. But yeah, if you want to include multiple renders in a very flexible way or bring in like some 3D positioning of additional elements or so, then I think this could be interesting even if you don't have two deep EXR files, but simply render layers with depth information. Finally, you can render out deep images if you need them somewhere else, or if you needed to create some form of deep assets or something, I don't know. If you ever find the need, use the Fusion Saver node, not the media page in Resolve. Again, also in DaVinci Resolve, you can use the Saver node. And this one normally creates your regular OpenEXR files. If you attach an image to this, you will just have your image files rendered, right? And you won't see much of a difference, but you can connect a deep image file as well. And it does render out as an OpenEXR 2.0 deep image, even though the settings and everything looks pretty much the same as far as I can tell. That was it for my introduction to the deep image toolchain. If you are using deep images already, or if you are currently thinking about a use case where you want to start doing this, I would be quite interested to hear about what kind of project are you working on and where are you using it, like what kind of size, etc. Deep images have been there for a while in Nuke and in like high-end Hollywood compositing tool chains, but then again the Fusion user base tends to be slightly different overall, so I'm kind of curious to see what Fusion users, what are you working on where this might make sense. So if you're using this already or start to use it now, let us know in the comments how it goes, and if there's anything in this tutorial that's missing for you, let me know, maybe we can figure it out. Alright? Thanks for watching, see you next time, cheers!